Hello, today we are going to do separation using acids and bases of a mixed compound containing salicylic acid, ethyl 4-amino benzoate, and naphthalene using a separatory funnel. So the first thing we're going to do is weigh out 2 grams of our crude product and put it in a beaker. So I'll just put it in there, and then we'll use 50 mils of our ether, put it in there, and there we go, and shake it, stir it up just to dissolve it. And there we go. So we're going to use our separatory funnel, which is in the back here, and I'll explain how to use it here. How it works is you have a stopcock on the bottom. So if this is in line, as you can see here, it will drain. If you have it this way, so it's perpendicular, it will not drain, it'll stay closed. And you have a stopper on the top that if you try to drain it with the stopper on there, it will not drain. So just know if you're draining it, it's not. Chances are you might have your stopper on, so don't do that. We're gonna take our sample, it's dissolved in the ether. We're gonna put it in our separatory funnel. Make sure your stopcock is closed, otherwise you will lose everything. So the first thing we're going to do is remove the ethyl 4-amino benzoate using 3 molar HCl solution. Now, what this is going to do is it's going to protonate the nitrogen, and it's going to create the salt, which is going to be soluble in the aqueous layer, which is going to be the HCl we're putting in. So if you remember, like dissolves like, in this case, ether isn't soluble with water or aqueous HL solution. So as you can see, you have a nice bilayer that's formed. So the top layer is your ether layer, the bottom is your aqueous layer, which is the HCl. It is more dense, it's on the bottom in this scenario. So next, what we're going to do is put our stopper on, and you're going to kind of stir this back and forth, and it's going to produce some gas, so be sure to vent it every so often. You can do that by having this facing up and opening your stopcock. The other way you can do it is you can just take the stopper off, as it will produce gas, and you don't want to have too much, otherwise it'll kind of pop your cap off. So you'll just keep doing this until there's no more gas evolution. The other thing too is when you're doing this, you just want to do it gently back and forth. You don't want to shake it like a martini mixer. Reason being is that will create something called an emulsion, and those are a real pain to deal with. So just do it back and forth gently until there's no more gas to avoid that. So next, what we're going to do, you're going to have label your glassware, HCl layer, or 4-amino benzoate, whichever works, because you don't want to mix anything. Otherwise, that'll cause issues with your extraction. So you're going to empty the bottom layer into here. all the way down until it's right there. You can see all the bottom layers gone, and then you're going to do this 3 more times with 10 mils of distilled water. So the reason being is because you made this salt, and the product, the salt, is now soluble in water. So being that it's soluble in water, you can pull it out with water. So again, this is going to produce some gas. So you'll just keep doing it until there's no more gas evolution. And you can kind of see our solution's getting clear again, just because all that salt's coming out in the water, which is what you want. You can see it's a little clearer this time. There is another layer, and that bottom layer is going to be the water, because water and ether don't mix. Ether's less dense than water, so we'll just drain that water into the HCl layer and keep it. Okay, so I have extracted it 3 times with 10 mils of water. So now we're going to take this and put it aside. We don't need it for now, so put it somewhere it won't spill and that it's safe. So next thing is you're going to label or do something to keep track of this. I've labeled it NaOH, sodium hydroxide layer, or the salicylic acid. So now we're going to do the same thing, but instead this time we are going to use sodium hydroxide 3-bar layer solution. Now what this is going to do is it's going to deprotonate the salicylic acid and turn it into the salt of the base, and we're going to extract it the exact same way we did before with the amino benzoate. So when you dump it in, same thing. You're going to see a bilayer show up, that kind of partition right there, and this is going to make the salt, the base salt of the salicylic acid. So put your cap on, kind of shake it back and forth, and do this until there's no more gas evolution. Let it sit for a couple seconds. You can see there's that bilayer again, and it's the same thing as before. The aqueous sodium hydroxide layer is the bottom, so you're going to drain that out, as it's going to contain the salt that you're looking for. So just like before, we're going to do 3 washes of 10 mils of water, and it'll make that bilayer again, and you're just going to gently shake it until there is no more gas evolution. Okay, so you can see there's one nice layer in there. That's your organic layer, the ether. So what you're going to do next is drain it into your Erlenmeyer flask, and then we have to dry it, because there might be some residual water from the water washes in the aqueous NaOH or HCl, so we need to remove that. So what we're going to use to do that is magnesium sulfate. So magnesium sulfate is a drying agent. It's good for removing any small amounts of residual water. All you're going to do is take it, just dump it in there. There you go. You can see it's on the bottom, and swish it around. So what you're looking for is it doesn't all clump up in the bottom, and it kind of looks like a snow globe when you stir it. So now what we have to do is filter this, and we will do that with a filter paper and your stemless funnel into your 100 ml round bottom flask. Be sure to weigh your dry round bottom flask before this. So let's set it up just as so, and just pour it and let it drain. Any magnesium sulfate is just going to get trapped in your filter, and you just let it drain. So next, what we have to do is we have to basify our amino benzoate. Now, to do this, you're going to start with about 15 pellets of sodium hydroxide, and you're just going to put it in there. And all you're going to do is stir it just with your stir rod, and you can see it's kind of looks like it's boiling because it is neutralizing a strong acid with a strong base. If you feel it might get a little warm, so I only do start with 15 and work your way up. And as this becomes more basic, you should start to see a precipitate form, which is going to be the amino benzoate. So while you're doing this, you're going to want to check the pH of it periodically, because you just need to basify the solution. So the way to do that, so you don't waste a lot of paper, it's just more efficient, is you take a pasture pipette, and you just dip it in there, just fills the end, and you just take it and put a few drops on your pH paper. You're waiting for this to turn blue, meaning it's basic. You can see it's still kind of reddish orange, so you need to add some more sodium hydroxide pellets. But you can see it's not clear anymore. It's starting to crash out a bit, and just keep adding them 4 or 5 at a time, and stirring it to dissolve them. So we added 5 more pellets, and then we'll check the pH again and see that is now blue, which means it is basic. So next thing we have to do is cool this off, so then everything will precipitate out of it. So if you want to put this in an ice bath and let it cool, and then you can move on to the next step with the salicylic acid. Okay, so next thing we're going to do is the exact same thing, but instead of using a strong base, we will use a strong acid, which is concentrated hydrochloric acid, and we will acidify the salicylic acid, and it should crash out as a precipitate or as a solid as well. So you're gonna take just a new pasture pipette and just put 1 full squirt of it in there, and then stir it around. You'll do this, and same thing, you will keep track of the pH until it is red. So if we check it here, you can see it's still very blue, which means you need more HCl, and you'll do this until it turns red as well. Okay, so you can see it's kind of light and cloudy. A precipitate is formed in it. That would be your salicylic acid. It's precipitating out. Now, what we're going to do is check the pH again. So you can see, that's now red, which means it's acidified, and all your salicylic acid should be out now. So now we're going to do the same thing and put this in the ice bath to cool for 10 to 15 minutes and let everything precipitate out. So now, in the meantime, while those are cooling, we can go take care of our ether layer. And what we're going to do is use the rotary vacuum, and it's going to evaporate all of the solvent off. So we'll go do that. Okay, so here we have the rotary evacuator. This is what we're going to use to remove the ether from our naphthalene. So it looks intimidating. Don't worry, it's not. It's very simple. So how this works is the first thing you're going to do is take your round bottom glass, this guy here, and just slide it on the end here. Clip it on so it's not going to fall off. Next thing you're going to do, so this is a water bath. It's heated to 40 degrees, and you need to lower your round bottom flask into there. So you just use the switch right here. Need some lube apparently. And as you can see, it's about halfway in the water, give or take. You just don't want it touching the bottom. So next what you're going to do is turn dial up like 3 or 4. As you can see, it's now spinning. So, and next part is this here. This is the vacuum pump. So it's going to be set. You don't really need to touch it. You just need to turn it on. And what it's going to do is it's going to put this whole chamber under a vacuum, and it's going to boil and evaporate your solvent. So you should be left with pure naphthalene. Now, the thing with this is both of these evacuators are running off the same vacuum pump. So whichever pump you have, you're going to have to open the stopcock for it so it will allow vacuum. And if you're not using it, be sure to close it when you're done. So if somebody else is using the other one, they won't lose vacuum, and theirs will keep working. Also, this is a gas trap. This is going to trap any ether that decides to make its way out. It's full of liquid nitrogen, so please don't touch it. Don't put your finger in it, just because it's really cold, like minus 196 degrees, so it will burn you very bad. Now the last thing you have to do is close the switch here. So if this is in line with this here, it means it's open and it will not go under vacuum. But if you close it 90 degrees, then that means that it will go under vacuum, and then your whole entire system will go under vacuum. So now all you have to do is turn on the pump, the switch is at the back, and then you just have to wait for it to do its thing. You see a little white line starting there. That's your naphthalene, and solvent's starting to boil. There we go. See, it looks kind of like a snow globe now. So that means all your ether's out. So leave it on for an extra 30-45 seconds. That'll remove any residual ether that is in there. Because if it's not dry, then it's going to give you a false amount of product that you have in there. Now that it's done, what you're going to do is you're going to come over here, you're going to shut the vacuum pump off, just switch on the back, and you're going to close this here. Then I'm going to turn that off. Here's the switch here. You're going to open it and release the vacuum. Raise this up all the way, and then you can grab this, take it off, and voila, have your pure naphthalene in there. So now you can go away this and make sure you dry the outside off really well. Otherwise, you might get a little higher of a yield because of the water on there. So these have been cooling for a while. So this is our salicylic acid. You can see there's a lot of crystals in there. So, and this is our benzoate. There's also a lot of crystals in there too. So now we have to isolate those, and what we're going to do is use our Buckner funnel. If you need to review how to do that, you can go back to the recrystallization lab and review it. So we'll do that, and then you'll want to collect them in beakers that you've weighed and see how much you have obtained. Okay, so we have our 3 isolated samples, our amino benzoate, salicylic acid, and our naphthalene. So the last thing we have to do with these is our melting point. The nice thing is you can do all 3 melting points at the same time, since our melting point apparatus has 3 holders in it. So when you're doing it, just a tip, watch the lowest melting point first, then go up from there, so you can do all 3 at once and keep track of it. Okay, to the melting points of all 3 of my products. So naphthalene literature melting point is 80 degrees. I got 68. It's a very simple reason why. All the ether wouldn't have been removed on the rotary vac. I took it off a little too early. Ether's got an extremely low boiling point, so that will make things melt way faster. The ethyl 4 amino benzoate, its literature is 88 to 92, and I got 80, so it could be a little bit of residual water, or it could be I didn't pack my capillary tube down enough. Those are both possible reasons. And the salicylic acid is 158 degrees literature. I got 152, so again, it could be a little bit of residual water in there, but overall it's not too bad. And for yields, the naphthalene, I got 471 milligrams, which is a 23.6%. The benzoate ended up with 29.8%. And salicylic acid, I got 28.9%. And total that is 82.3% yield. So I ended up losing 17.7% along the way. It could have been from a few different areas. One of the easiest areas would have been it didn't get acidified enough. It didn't let cool off and crash out of solution. Those are 2 very simple reasons. There's several other reasons as well that it could be. So now keep all 3 of your products in your locker for next week. because you're going to need them for the TLC lab, so do not throw them out, otherwise you will not be able to do the TLC lab.